Are your data scientists and developers aware of ML security threats and model failure modes? Why this principle? Security by design is a key principle in traditional software development. When developing systems with an ML component, it's important that threats and mitigations specific to ML systems are understood alongside traditional software security standards. Developers aren't always security or usability experts, but understanding where decisions affect security and how to design and implement a solution that works for its intended users are crucial parts of ensuring that security works in practice. It's therefore important to establish a positive security culture, supported by leaders, providing sufficient credibility so that security is considered at the start of a project. Studies have shown that many ML practitioners aren't aware of the specific vulnerabilities of many ML algorithms or don't have the right tools to assess these vulnerabilities in the first place. This can create a poor security culture and heightens the risk of vulnerabilities being introduced to a system. In addition, as the push to low-code and automated ML continues, it's also important to think about the background and skills of people using these systems who are less likely to be developers. Although they may not consider themselves to be writing programs or systems, they are still using underlying ML techniques that contain security vulnerabilities. Understanding these will help them make the right design decisions that are proportionate to a project's security requirements, as well as promoting security throughout the development. What are the goals of this principle? Ensuring that your ML practitioners, data scientists, and software developers are familiar with the inherent vulnerabilities and failure modes in ML workflows and algorithms. They should follow best practices to reasonably mitigate the threats associated with them. Security is considered a key part of your ML project and integrated into your workflows. Your team members at all levels understand this. Strengthen your people. Enable and encourage a positive security culture and accountability by ensuring team members have the relevant security knowledge. Support this by providing training on the threats that are unique to ML components, where knowledge gaps are identified. Guidance. A security-centric culture requires training and requires all stakeholders involved in the ML lifecycle, from requirements to operational use, to understand the threats to a system, including ones unique and inherent to ML. You should therefore be prepared to invest time and resources to promote this. The NCSC has guidance on growing a positive security culture and how people shape security. Understand that security is not always part of formal data science or ML course curricula, and that expertise in these areas may not translate to knowledge of system security. Even when best security practice is understood in theory, its practical use should still be encouraged. Technical team members working on model development should be familiar with a range of attacks on ML systems. Some of these attacks are highlighted in this Microsoft blog on failure modes in machine learning and in the MITRE ATLAS framework. ATLAS is a knowledge base of adversary tactics, techniques, and case studies for ML systems based on real-world observation, demonstrations from ML red teams and security groups, and the state of the possible from academic research. As research in this field is fast-moving, you should make sure that practitioners receive the right support to keep up to date with the latest attacks and vulnerabilities for ML techniques, or any other common vulnerabilities and exposures on applicable assets, such as models and datasets or relevant software. A method capturing ML-related objective is cyber exercising. Strengthen your approach, processes, development. Encourage best security practices by making sure security reviews are integrated into your system lifecycle processes. Make people accountable for these processes and use automation where appropriate. Guidance. Each application's development lifecycle will be different, and it's important to integrate security reviews appropriately. For example, if you take an agile approach to development, consider integrating security reviews into each sprint. If teams are aware of and accountable for security-related responsibilities through the lifecycle, it encourages a positive security culture. Depending on your specific development process, automated security testing may be an option, although it's still important to have a security-centered culture. See below for guidance on incorporating security-focused activities throughout the development lifecycle, although it's important to tailor advice and implementation to your own requirements. NCSC Guidance on Secure Development and Deployment, OWASP Securing the SDLC,